our speaker today, traveling from California. His name is Avik. He worked as a data scientist and machine learning engineer in California. So today his topic, he mostly worked in time series expertise. And then let's give the floor to Avik.
All right, thank you everyone. I'm super stoked to be here. Thank you all for joining. Today I'm going to talk about something that I've been playing around with for a while now. Hopefully I'm getting better on that. So it's about producing reproducible work environments, when I talk about that, I'm talking especially from the point of view of a data science project. So that's what we're going to look into. So a little bit about me. I'm based in Sunnyvale, in the Bay Area. I am a staff data scientist at Intuit, where I work with many of the time series models for revenue prediction and all of that, especially for TurboTax. That's my day-to-day work. So I come from a background of data science and engineering, which makes me just eligible to be in that zone where I can go both ways and do a little bit more with some of the engineering aspects as well. So I love RPG games, especially PS5. So Ghost of Tsushima, Last of Us, Spider-Man, all of those are my favorite. I also think that driving is very therapeutic for me, especially if the car is fun. It has a manual transmission and the roads are curvy and there is no minivan or a big SUV in front of me. So given all that, let's get started. So I first want,
your PowerPoint's not on. It's not running.
So you can go to the talk schedules. So Avik has posted the slides on the description page, so you can see the PowerPoint on your computer.
So first of all, I'm going to start with what does really something deterministic, what does it really mean for a deterministic behavior of a system, right? So the formal definition is that we want to replicate the exact same outcome of an experiment across different work environments. Okay, that work environment could be anything. It could be my machine. It could be, something in production. It could be anything. So I want to replicate the same exact thing, across different computing environments. It sounds simple, right? But why is it really that important to have that behavior? Well, a couple of things. Right. First of all, it ensures consistency. Right. So if you have a deterministic output, you can be assured that your work, whatever you're working on and whatever the output is, on your own machine, is going to translate to the work in production. Okay. The second thing is, it allows for collaboration. You don't want to hear again, it works on my machine, all of those sorts, right? So it allows for better collaboration and it speeds up just the development velocity there. It also provides transparency, right? Because things are pretty verifiable. If you want to share this to another stakeholder in your project, they can look at it, even though they are non-technical. And finally, it maintains some integrity, especially true for data science projects, just because just the stochastic nature of it. So it's very important for that as well. So I'm just going to briefly talk about some of the components of deterministic behaviors from a data science standpoint. There are really 4 components to it. So if you think about it, the first one is the code. By code, I mean anything and everything that comes within and shipped with the code. So this could be the project version, the actual project that you're working on. It could be the scripts, the notebooks, your modules, your Python modules, or R modules, whatever, right? And other config files. The second thing, the most obvious one, is data. So the data has to be the same, whatever you're working on and whatever you are expecting things to work on, right? So it has to be the same data sets and the same data sources. And then you have the models, especially for our use case, we deal with a lot of like ML models, right? So the versioning is very important. Random seeds, you have to really make sure that you have set a particular seed, like in my seed behavior. So that is one thing. And then, of course, there is something that you can't really control, which is the model stochasticity. And so I've actually given a link below on this slide where, in Torch, there are some, functionalities which are just not deterministic at all. And then finally, we come with the environment. And in the environment, I'm talking about not only the package itself, but also its own dependencies. So it could be Pythonic packages or anything which is non-Python as well. And I'm also talking about the OS versions as well. So those also come into the environment. Now, I want to order this. I want to order these different levels of components into the level of, I would say, the complexity of deterministic behavior. So the first one, the code is very easy. If you have the right code, the same code, it is the most easiest thing to fix. Then you have data. Data, mostly it's still under our control. We just have to make some checks to make sure that the data is what it is. Then you have the models. As I said, the models are a little bit tricky, but still you have bandwidth to play with, right? You know that, okay, it's going to be around this much to this much. But the most difficult one is actually the environment. That how do I fix the environment so that it is reproducible and it's kind of immutable? Well, why is a deterministic environment such a hard thing to create, right? Because if you just think about from a Python standpoint, a Python project standpoint, where there are dependency versions, you have Python versions as well, you have non-Python dependencies, which is actually fairly more common in the scientific community, right? You have a lot of non-Pythonic dependencies, and also the type of operating system. Whether you have Windows, Mac, or Linux, even the versions within that ecosystem is also something that can change certain things. I have had to deal with many different things that I actually stopped myself from upgrading my Mac before this talk. It's just because I don't want things to break, right? So, and then also a different platform architecture, like ARM, x86, and all that. So, what are the different solutions out there? I mean, there are actually many different solutions, and we are already utilizing some of those. So, the first one is a very simple one, is a Python package manager. So, we have upgraded ourselves from just having just a requirements.txt file, right? So, we have something that we're using and all of these tools, right? The Poetry, PDM, UV, Vipent, like all of that just gives us a bit of way to work with, and just provide the dependency locking that we need for, for creating a consistent dev environment. And it provides dependency locking for both the direct dependencies, the ones that you directly depend on, and also the transitive dependencies, which those dependencies which you directly depend on are actually dependent on, right? So, and you also can provide the version locking, right? Something you can say that, hey, I just want Python 3.10, nothing more, right? And it will just work. But the one good thing about all of these package managers is that these things are declarative. Now, what do I mean by declarative? Declarative means that I just write down the steps I need, or I just write down the kind of state I want my system to be in. Okay, I don't need to really write the steps. Okay, go from here to here, do this and that. No, I just say that, hey, I just need NumPy, I need pandas, and that's it, right? So that's pretty cool. But there are obviously some cons associated with it, and especially when it comes to some non-Python dependencies, especially C, C++, Rust, and many of the scientific computing, as I said, so libraries can fall in this. And one big con of this is that we are only talking about the Python environment. We are not really talking about the full dev environment, which includes many, many other things. It's not just your own ecosystem. There are actually many things that are associated with that system in itself, which can really take the charge, right? So the next one is very simple at this core, which is Docker containers. Docker containers is the go-to standard for everything in production, right? So it has great documentation, great support, even for development, dev containers have been really gaining the popularity these days as well. And it can actually capture the whole dev environment here. But there are some cons associated with it, and especially when it comes to development. One of them is that it can really bog down your whole system because it's really resource intensive, especially when it comes to some containers which, let's say you're using Torch or Chats or all of those deep learning libraries, they take a lot of system resources, and it can be intensive. Another big one is that the configuration is imperative. So what I mean by that here, it's not declarative. Here you are actually specifying the steps needed in a Docker file to reach that configuration that you hope that the environment reaches. Okay, so that's a problem. And then of course you have some security vulnerabilities. For example, if you're pulling in a very old version of Debian, it can cause issues in your system because your system is sharing resources with that Docker container. Okay? Obviously the main thing is that it might be just an overkill for development purposes, at least from my standpoint and what I have experience with it. So that's what it brings us to Nix. Okay, and Nix is something fairly new, at least to me, but I've been playing around it for a while. So what is it? So it's actually a package manager. So you can think of it as pip basically in Python. Okay. So it's a purely functional package manager, and by purely functional, it means that it actually treats these packages as just values in a functional programming language. So they're completely immutable. You don't really change. So they don't have any side effects, and they actually never change after they're built. Which means that all of the upgrades or rollbacks are atomic. You will never be in a state where it just happened and you're midway, in a limbo state. That will never happen. It will either be upgraded or it will never happen, right? And the way it does is that it stores these packages in a hashed way, right? And even if you upgrade it, you're not really overwriting that package. You are just going over, you're actually creating a new hash and then saving it again. Okay, so there is no version conflict whatsoever. Okay, the best thing about this is that it's declarative, and it's declarative in the whole, I would say, in the whole holistic sense. It's not just only you are saying only the Python part of it is declarative. It's actually the whole build environment that is declarative. Okay, so and again, the core idea revolves around reliability and reproducibility. Okay, so there are actually some components of the Nix ecosystem that I want to talk about a little bit. The first one that I just talked about is the packaging, right? The package manager, which is analogous to pip. That's the way I like to think of it. Then you have the Nix language. The Nix language is purely functional. It's dynamically typed. It's lazy evaluation done as well. And then you have the Nix OS, which is think of the declarative environment, so everything that you want to declare, and then transform it into a full distributed Linux distribution. Okay, and then you have the Nix packages, which they claim to be is the largest and the most up-to-date software distribution available. And I think of it as analogous to PyPI, right? So, but for all the packages there. And then you have the Nix shell, where you can just type Nix shell and then it will create that shell environment for you to play around with and just work through it. So I like to think of it as similar to the virtual environment, like in the Python world. Yeah. So we'll now go over a sample project here. So a sample project which is very simple. I just did that, and this is the core idea of this is to show that how can we create something, and I deliberately made it very simple so that it's easy to understand. So on the right, you can see that this is my Py project almost. And in the dependencies, you can see that I just have three things: the matplotlib, numpy, and pandas. Now I wanted to go conservative on this, so which means that it's basically numpy, for example. I just don't want any version more than 2.1. So any patch versions are okay, like 2.1.10, that's fine. But I don't want to go to 2.2. I just want to be very conservative with my versioning. I don't want things to break at all. I want just my whole environment to be immutable. Okay. And the whole thing that it does is it just plots the data. So you can see the data on the right, and it's just a time series that I just grabbed from my own system, and it just looks like this. Okay, this is the pattern, and what you do is you just run this command, Python -m source.plot, and it just plots this graph right here, and that's all it does. But there are some other things you can see there. So I'm using UV here because it's something that I'm working with and trying. So trying it out. So I thought, why not? So we have the log file, we have the Python terminal, we have the source file, the data, and then we also have, you can see there's a default.nix file, which I'll come to later. So now the thing is that I have everything I need, right? I have the UV setup, so it's a deterministic Python environment, so we're good there. But what if I want to share this project with someone, right? To somebody who is not familiar with Python. So it could be, so I've actually come across my colleagues who are great engineers. Okay, they are great C++ and Golang people. They're just not familiar with Python and they just don't have the environment set up. So what do I do with that? Or if someone does not have any Python installed. Now a default Windows machine, for example, does not have Python installed, so you have to install it. So it could be that person. Or you want to give this project to someone non-technical. It could be some product manager, or it could be some some other stakeholder you just want to share this project with, right? And then, or it could be one of many attendees in your hands-on workshop. You just want to share your project or your tool or whatever, and you just want to give them a complete environment to work with, and something that is nobody will come up to you and say that, hey, it's not working, on my machine or something, right? So that's the whole idea here. So what do? So we first add the default.nix file in the main directory. Okay. On the right, you can see that there is this, this code that we have where it is written in the Nix language. Okay, and it looks complicated, but I'll just break that down. Right. So the first part is let. That let block basically defines some variables that you want to use later on. And also you're importing some packages. So think of it as like the import statement in Python, right? So you're importing the packages, the Nix packages there, and you're saying that, hey, I want all the packages in Python 3. So in Python 3.12, because that's what we had in our system, right? And then the next one is the main block where you have the in block. The in block, what it does is that it basically is the main configuration block. And you're basically saying that, hey, create a shell. This empty shell no CC basically means that create a lightweight build environment which does not have the C compiler tools, because you just want to run this, right? You don't need all of that. And with packages basically means that you are using that namespace in packages so that down below you don't have to do packages.perl. You can just do perl, right? And then you define your packages. Again, we just have 3 packages there, right? So we have NumPy, pandas, and matplotlib. So you get that. And then you also add some non-Python dependencies. Something that you want your build environment to be with. So it could be the Perl, like for example. I don't need that, I just added just for demonstration purposes here. And then the last one is a shell hook. Shell hook basically acts like a constructor, you can say. A constructor meaning that when you invoke the shell, this command will be run automatically. Okay? And the way you run it is that you just type Nix shell. Like on the left, the first time when you run it, it will actually download some files there, and it will show, plotting the data and everything, and then boom, you're inside the Nix shell. Okay, so that's what's going on here. So this gives us a completely immutable environment. Okay, but it's not exactly what we want to do, because what you see is if you go inside. So what I did was I just went inside and I just did a pip list. Okay, and I want to see all the packages that are out there. You can see that the NumPy version is 1.26. That's not something that I really wanted in the first place. Okay. Now we're going to debug why is that the case. Okay. And when I did which Python, it actually gave me the right one because it's inside the Nix store. As I said, every package. So in Python also is a package inside Nix. Okay. So it stores inside this, and so we're good there. But we want to debug why the NumPy version is 1.26.4. Okay, so then there's a website that Nix actually you can actually search all the packages out there in Nix. And when I did the search, and I did the search for the latest channel, which is available, like of Nix, which is 24.05, and I wanted only the Python 3.12 packages, I could see that the NumPy package is actually only available as 1.26.4, which is the one that I have, which is good in terms of, okay, it is the one that it's like showing me about, but it's not really the one I want, right? So which means that in this channel, this one will never change. So it is completely immutable. But we're going to do some work to make sure that we have the right NumPy version there, right? So what we do, well, we install from PyPI, because that's where the latest and greatest versions of Python packages exist, right? So we are going to install from that. So that's how we'll fix our dependencies. So on the right, you can see that we added a bit more work there, but it's not really that much. So the first line, so now what we are doing is we're actually freezing the version of the Nix OS that I want from. Okay, I'm actually saying get the packages from this version of Nix OS. Now what does that do? That basically makes sure that all of the packages, every package, I'm not talking about just the Python packages, every package in the build environment is completely frozen now. It's not going to change as long as I have the same exact version. So when I mentioned that this actually is foolproof in terms of immutability, okay? So that's what we're doing. Then what we changed is that we actually removed everything from the Python packages that we had described earlier, like the NumPy, matplotlib, and pandas, and we just added one thing, which is the VNV shell hook. That just makes it easy for us to build a virtual environment inside Nix. Okay, that's all. And then the shell hook, we're doing the real work. There, what we're doing is we are defining the virtual environment pretty easy. We're just saying minus mvnv. We're sourcing it, means we are activating the virtual environment, and we're adding it to the path. Okay. Then we are installing from the requirements.txt. Now remember, this requirements.txt is not just a normal one. It's actually exported from UV. Okay. So I lock the UV log file, right, and then I export those dependencies into this requirements.txt. So this is completely frozen, by the way. So I install it, and then I run my command. And in the post shell, as the name suggests, it's basically after the shell hook runs, what you do is some finalizing configurations, and in this case, you're making sure that your virtual environment has access to some of the other packages that Nix had installed. Okay, so it's in that path. So that's all we are doing. All right. So here, what did we see? We do not use packages from Nix packages or the Python packages from Nix packages. We are using from PyPI. We use the virtual environment. And by the way, the requirements.txt, as I said, is exported using UV. Okay? And this is just one of the many ways of achieving this. I just made it work, and I've been using this for a while now, and it just works for me. But there are multiple other ways of doing it. So let's validate what we did. So when I did which Python, I can see that it's now different. It's now the VNV that I want. Okay, so it's the VNV inside the project that I want. Okay, and that's good. And when I did the pip list, I can see that the NumPy has the right version. Okay, which I really wanted from the log file itself. So the question comes that how can someone else run my project in a deterministic manner? Well, they just have to install Nix and run Nix shell. That's all. Okay, so that's the only prerequisite I have for those people, is that just install Nix in your system, and then we're good. Now, of course, there are no free lunch. There are some drawbacks. As you can see, it was a hard language to learn for me. Especially, I don't come from a systems engineering background. Okay, so I don't know all of that. So it was a hard language for me to grasp. And then the concepts itself are pretty complex. It needs a lot of, if you want to really go deep into it, it's actually very deep operating system concepts and everything. It's not beginner friendly, and I don't know why, but it's not very widely adopted in the Python community as well, which is why I'm here. And then there's also a minor performance overhead. It's not much, it's getting better, but there is a slight one, especially if you deal with CUDA and all of that, in your Nix environment. That's what I saw. Now there are some other tools in the ecosystem which can make your life easier. I have been making my hands dirty with these tools, but we'll see how it goes. The first one is Nix Flakes. I think it's one of the most popular tools out there. And what it does is that it tries to create a level of abstraction, and it provides a uniform structure for all of the Nix projects. So like we have a log file, like maybe in poetry.log or uv.log, it tries to pin all the dependencies that you have in a flakes.log file. Okay. The problem is that it's still experimental, even though many people are using it. That's probably the only thing there. But they also have a lot of templates for Python applications as well. So maybe there's something to look to. Then you have the dev env. It's something that I came across also fairly recently. It's written in Nix, but the output that you work with is actually a JSON-like language. You're not really working with this very difficult language in Nix, right? It's declarative, it's reproducible, and it's the whole idea is not to put this in production, but to have a composable dev environment. Okay. So, and it supports more than 50 languages, I believe. So it's pretty cool there, but I'm still working my way through it. So let's see how that. Yeah. Thank you. And any questions would be greatly appreciated.
Thanks, Agi and everyone for being able to accommodate us for the technical difficulties this morning. So we're opening up 5 minutes for questions. If you have any questions, raise your hand. I'll get the mic to you.
Thank you for your talk.
But this floor is all
Sure,
striped
it's
this
pretty,
morning.
it's a pretty small room, so.
Yeah.
I was just curious, it was cool how you showed how to deal with the NumPy version, even if it wasn't what you expected. Will the sort of atomic upgrades and downgrades still work if you use that approach? Because it seemed like some of the work was being done with the Python package manager.
That's right. So the way I showed, right? So I think that's a very good question, because you're taking a little bit of power away from Nix, and you're saying that, okay, I'm just gonna trust on UV or all of these other tools to make that work. Yes. So, but it will still work because it's actually a transitive dependency, right? Because you're making sure that your Python environment is rock solid. That will make sure that your whole system is immutable. Okay. So Nix will make sure that other things which we are not really concerned about, but those are really important, like the other non-Python dependencies, like the C library, the C compilers, and everything. Those are handled by Nix, and then you're using the log files from poetry or whatever, right? And that will make sure that you have a consistent environment. So it's not going to affect it at all, and it will still work.
Great.
Yeah.
And there's another question there, back there, just now, or okay, you can go.
Yeah. Can you help me paint the picture better between the difference using Docker containers and the Nix? Because like from the demo, the last piece, it sounded like very similar to as if I would build a Docker container and just use that.
Yeah. So the problem with Docker is that Docker is great, and it's great to use it on production. Okay. The problem is you have to declare a set of steps that works. I don't know about you, but a lot of times that has happened to me is that okay, I have my own Docker file. I have a Docker container running in CI. I have another thing running in production. Okay, the same in Docker. I make a change. I'm excited about it, and boom, the CI fails. Okay, there is something happening there because you upgrade something and something fails there, right? Because it could be a different Debian version. It could be anything. It could be the image that you import from, right? You do import from a base Docker image, right? So maybe something happened there, which you don't have control over because somebody else is doing that, okay? And that would actually break things up. With Nix, you actually remove that little bit of variance that that comes with Docker. Okay, and you can also, by the way, you can also use NICs on Docker containers. Okay, so that's also possible, and people are exploring that aspect as well to just foolproof everything there. So yeah, it's a slippery slope, but I feel that in terms of the dev environment, NICs is like superior. In terms of the production environment, Docker is superior because it's easy to deploy.
Any other questions? Okay, so let's give another round of applause for